Hello everyone, my name is Aaron Stannard. I'm the founder and CEO here at Petabridge, and today we're going to talk about the new libraries we introduced as part of our Akka.NET 1.5 development effort, Akka Hosting, Akka HealthChecks, and Akka Management. Now, if you're interested in learning about the changes we made to the core Akka.NET DLLs and Akka.NET 1.5, we have a separate video we've already produced on that. Go ahead and click on the link in the description or up above, and you'll get a chance to see what those are all about. But in this video, we're going to go ahead and focus on the three new major libraries we released and developed as part of the Akka.NET 1.5 development effort, the most consequential of which is Akka Hosting. We've already done a couple of little videos on this, but we're going to go ahead and touch on the finished product here and some of the new content we added to it after we initially released it like last April, roughly. So what Akka Hosting is all about is primarily it's designed to streamline the way you configure and manage your Akka.NET applications. It boasts full Microsoft.Extensions.Configuration and hosting support to a point where you don't even need any HOCON at all to configure even fairly complicated Akka.NET applications. We have little fluent C# builder methods you can use for all of them, and you can also parse HOCON directly from a Microsoft.Extensions.Configuration source now, such as an app settings.json file. We also have full support for integrating with Microsoft.Extensions.Logging, so you can go ahead and easily take any data that's being logged via the Akka.NET logging adapter and pipe it out to your Microsoft.Extensions.Logging factory if you want to. That's all fully enabled now. And then on top of that, we really improved dependency injection support quite a bit. It's now very easy to pass a strongly typed reference to an actor into a non-Akka.NET source, such as an MVC controller, a SignalR hub, or maybe a gRPC service. And this is done through the ActorRegistry interface, as well as our ActorRegistry that we're going to learn a bit about. And finally, the ActorRegistry also includes a getAsync method, which will allow you to go ahead and asynchronously resolve a reference to an actor that might be not inserted immediately when the actor system starts up. You might have to wait for some other actors to start before that entry in the registry gets populated. Well, this will allow you to wait for that asynchronously if you want to. Next, we have the Akka.HealthCheck library. Now, this existed in some way, shape, or form for a number of years, but now we've officially streamlined it and made it a lot more supportable for work with, let's say, the Microsoft.Extensions.HealthChecks library, which includes things like the HealthCheck service that's really popular inside ASP.NET applications. We have some built-in health checks that ship right out of the box. We use Kubernetes-style liveness plus readiness sort of distinctions. So we have probes that are designed to go ahead and test to see if Akka.Persistence is working correctly, if you're currently in a live running cluster right now, and it's also very easy to write your own health checks using Akka.HealthCheck. And this all integrates really nicely with Akka Hosting. Lastly, the third library we've introduced is really for Akka.Cluster users specifically, and this is Akka.Management. Akka.Management is designed to make it possible to bootstrap Akka.NET clusters without needing Lighthouse, which is the static seed node service that many Akka.NET developers have been using for years. You don't need static seed nodes anymore. You can actually dynamically discover your seed nodes using the Akka.Discovery plugins that are shipping as part of the Akka.Management library. And then there's also the Akka.Management DLL itself, which uses that discovery data and exposes kind of an additional HTTP API to pre-negotiate who's going to be in the cluster with whom and who's currently part of one right now, and it uses that to help dynamically form clusters. So this will reduce your infrastructure costs. It'll also make it possible to run Akka.Cluster inside environments that are, let's say, fairly lightweight platform as a service environments, such as Azure App Service or Azure Container Apps or Amazon ECS, for instance. Akka.Cluster can now run with no problems in all of those environments, thanks to some of the discovery and bootstrapping plugins we have shipped. So we're going to cover all three of these today. So the first big library is the most consequential one, and that's Akka Hosting. Akka.Hosting really introduces four key feature areas that are really going to help Akka.NET users quite a bit. The first is the configuration experience. You no longer need HOCON if you don't want to use it. You can still use HOCON. We have an add HOCON and add HOCON file method, but by and large, you can now configure Akka.NET using C# POCO objects and populating them using Microsoft.Extensions.Configuration. So that means you can parse HOCON directly from an app settings.json file if you want to. That is one thing we support. Or you could use a strongly typed configuration section, many of which we offer out of the box, and parse that from the combination of different configuration sources you might want to use. The second is that we tie in directly to the Microsoft.Extensions.Hosting ecosystem. So the actor system is actually going to get started behind the scenes in a hosted service, and we're going to manage that using all of the lifecycle best practices. That way, that's no longer a thing you have to think about as an Akka.NET end user. Third, dependency injection is vastly improved, both with injecting things into actors, but also injecting actors into things. We support that in both directions now. And then finally, we also have the logging integration support, the ability to really easily integrate Akka.NET with the Microsoft.Extensions.Logging ecosystem. So let's go ahead and dive into it and see first, how do I actually install Akka.Hosting? Well, we do this by adding either the Akka.Cluster hosting NuGet package or one of these other .hosting packages you'll see published under the official Akka organization. So Akka.Cluster hosting is what I typically use when I'm doing work on distributed systems. That's going to pull in all of the methods for configuring cluster sharding, cluster singletons, distributed data, and not to mention Akka.Remote and Akka.Cluster as well. So that's all quite useful. Separately, if you want to go ahead and configure Akka.Persistence, we have an Akka.Persistence.SQL Server.Hosting, Postgres.Hosting, and we'll be shipping some other ones from MongoDB. I think there's already one for Azure that's out there right now, and there'll be one for Redis shortly as well. So the whole ecosystem for Akka.NET should be covered with hosting methods that are built in. And the other thing that's really convenient about Akka.Hosting is it's really extensible. It's really easy to go ahead and write your own custom configuration methods that if you want. And a best practice is populating those extension methods into, let's say, a shared DLL that you might use across multiple services that are all going to be in the same cluster. And that'll allow you to go ahead and guarantee that that same thing is configured the exact same way across all services, because it's literally the same code responsible for doing it. So this really helps improve, in my opinion, reuse of code, and it also helps improve consistency and standardization as well. Here's an example of a full end-to-end application, minus the actor type definitions, that is built using Akka.Hosting. First, we go ahead and we have our little namespace here, Akka.Hosting. We're starting up a new host using Microsoft.Extensions. And then we have our configure services method. This is where we're going to populate the service collection that we're going to register Akka.Hosting into. And at this add Akka method that's primarily responsible for configuring your actor system. We pass in the name of our actor system right here, and then we have this little builder right here. This is the Akka configuration builder. And you can build extension methods that piggyback off of this and do things like instantiate actors, or inject configuration, or maybe it might start a cluster shard region, or whatever you want. It's all highly composable and highly reusable. And that's one of the beauties of the way we've designed this sort of static extension method system for Akka hosting. It works very similarly to what people do with Microsoft.Extensions.Hosting today. The only difference is that we're going to go ahead and instantiate and run all of this in a little I-hosted service that gets registered behind the scenes when you call the add Akka method. So we're actually going to be responsible for executing all of this. Now, when you start working with real production applications that have a substantial amount of configuration, this is one of the practices you're going to want to adopt. Developing a strongly typed configuration section that you can parse from your Microsoft.Extensions.Configuration sources. In this case here, this is just a little Akka settings class I've named. I'm going to extract the name of my actor system. I can use configuration toggles now to really easily turn features on and off inside Akka.NET. So I can go ahead and turn clustering off if I want to, for instance. I'm going to configure my little extension methods that are responsible for configuring my actor system to look at this setting. And if I don't want clustering on, I'm going to run all my actors as local, in-memory, in-process actors. This can be really useful, for instance, if I'm doing unit testing. Alternatively, these sections right here, the remote options, cluster options, shard options, these types are all built directly into Akka.Hosting, so you don't need to define them yourself. You can go ahead and parse them directly from Microsoft.Extensions.Configuration and pass them into the configure Akka remote, configure Akka cluster methods if you want to. The other thing that I really like is the ability to dynamically configure some of these objects. So for instance, the public host name, I'm setting that equal to dns.getHostName. That would have been something I would have had to have written a special little function for in Akka.NET 1.4. But with Akka hosting, I can go ahead and just say, you know what? The default value is going to be the result of this static method right here, dns.getHostName. But in the event that I want to explicitly configure what my host name is, maybe I'm running in an environment that uses network address translation, like a cloud environment typically operates that way. I can go ahead and override this setting via an environment variable or via an app settings.json value, and that'll replace the public host name value with whatever is specified in config. That's really powerful and highly composable and a lot easier and simpler to do than it was with just plain old HOCON before. The way this would look in practice is I would have my little Akka settings, let's say JSON object defines app settings.json here, and I'd specify my cluster roles, my seed nodes. I might specify what state store mode I'm going to use for cluster sharding. And then I might also have some other settings for things like Akka.Management if I want to. Well, what I'll do here is I'll go ahead and have my builder add my JSON files and then add my environment variables. That way environment variables kind of get the final say on whatever our true sort of configuration value is going to be. And I can just parse those configuration values out of all of those configuration sources using this getRequiredSection method. This is part of the Microsoft.Extensions.Configuration API. And then I say get Akka settings. This will automatically parse all those JSON objects, all those environment variables into the equivalent types I'm expecting. It'll go ahead and do that recursively throughout my entire object graph. And now I have a bunch of C# objects, some POCOs I can work with to configure all the different little pieces of my application. So you can see here I parse that value. I go ahead and I call add Akka and I pass in my actor system name that I parsed out here. And then I call configure actor system. And this extension method that I defined, which extends the Akka configuration builder, I'm going to go ahead and resolve my Akka settings again. And I'm going to pass that value into configure network, configure persistence, and then I'm configuring some actors down here as well. So this eliminates all of the HOCON from my application. I'm now dealing with just settings options that are expressed on little simple POCO types, and I'm just passing those around to all the different little extension methods I can use to build and configure my actor system. This is the basic idea behind Akka hosting, is that you should be able to get away from string-based HOCON configuration and instead work with more strongly typed configuration methods that are highly reusable and very easy to kind of understand what they're doing from the outside. If you're familiar with HOCON and still enjoy working with it, one other setting that we do expose in Akka.Hosting is you can actually define HOCON directly inside, let's say, this little Akka section right here. And you can go ahead and parse that directly into HOCON via Microsoft.Extensions. So I can go ahead and call, services to add Akka. This is how we start with Akka.Hosting. And then down here I say get configuration section Akka, and I just pass that into the add HOCON method of my configuration builder. That'll automatically parse all of the HOCON out of this object right here and inject it directly as HOCON into my actor system. So if you want to dynamically populate HOCON via environment variables or via an app settings.json file, that is also something that you can do. This is an alternative to using the little POCO objects that I showed earlier. But the real benefit to Akka.Hosting isn't necessarily working just directly with configuration. It's also the fact that your methods that you use for configuring how your Akka.NET applications are going to run are static, and they're strongly typed, and they're reusable. So for instance, my configure counter actors method right here, you saw me calling that just a couple slides ago. Well, if I have use clustering enabled, then I'm going to go ahead and create a shard region for my counter actor. But if I don't have that enabled, I'm going to go ahead and create a generic child per entity parent, and I'm going to go ahead and register that to the registry as a counter actor. My tests that I'm using should still basically expect kind of equivalent results whenever I send messages to this actor, regardless of whether it's hosted as a shard region or it's hosted as an in-memory actor hierarchy. That should really not make a meaningful difference in terms of the semantics of my application. But this makes it really easy to go ahead and use the exact same method that you use in production in your unit tests as well. This will help improve test coverage in an actually meaningful way when you do this. So this is really useful as well. And it's a practice that I saw a lot of users engaging in on their own back in the days of Akka.NET 1.3 and 1.4. And we felt like we should offer a first-party way of doing this. And that's what Akka.Hosting is really all about. Giving you the ability to simplify your configuration, make it understandable for developers on your team who might be new to Akka.NET, and make it highly repeatable and reusable and strongly typed as well. So these are all some of the great things that Akka.Hosting can do. Lastly, you can kind of see that when we've composed everything into this configure web API Akka method, I usually saw the body of this method a few slides ago. I can go ahead and just call this when I'm building up, let's say, my minimal web API, and I know that all the little details around starting actors, managing their lifecycle, configuring Akka.Remote, configuring Akka.Persistence, all that can now be safely handled under the covers without you having to write a lot of your own boilerplate configuration code for doing it. You can have a couple of simple static extension methods like we had, put them into a shared library, and then just go ahead and pick and choose the ones that you need, or compose them together into one method that targets the service collection directly, like how I did right here with my configure web API Akka method. So this makes it really easy for us to do things like test production configuration inside a unit test. So you can see me using the new Akka.Hosting.TestKit, which is another thing that we shipped as part of Akka.Hosting. This makes it really easy to build integration tests, and we're using this quite heavily inside Phobos and some of our other products right now, where I can go ahead and configure a brand new iHost every single time I have a test method inside my fixture. And I can go ahead and do things like populate a singleton service that I'm going to use right here. And then I can go ahead and configure my actors to consume it. This allows me to validate that my configuration I use in production is going to work similarly to what I do during testing. So this is, again, kind of helping us standardize and streamline the way parts of our application are used, and trying to help improve test coverage and really just generally make it a lot easier for Akka.net to integrate with all the other parts of the Microsoft.Extensions ecosystem you're already using, such as, in this case, Microsoft.Extensions.Logging, for instance. Right here, you can go ahead and see we have this configure loggers method attached to the Akka configuration builder. Well, I can call down here, add logger factory, and this means that we're going to resolve via dependency injection a logger factory that's populated as part of the normal Microsoft.Extensions.Hosting stuff, and we're going to go ahead and pipe our output from the built-in Akka.net logging adapters to that logging factory. That way your stream of output from both ASP.NET and Akka.net can both be sent to the same destination. So that's another thing that we've kind of made really easy to streamline with Akka.Hosting. Now, the last thing we're going to touch on is dependency injection. This is another area that we felt that needed some improvement over Akka.net 1.4. And so we've done this via a combination of two different little constructs. The first construct is the actor registry. Now, we covered this in our initial video where we introduced Akka.Hosting. This is one of the key innovations that we introduced. But the actor registry is basically a dictionary that exists inside a single actor system. And this dictionary is going to use a strongly typed key. So in this case, we're using the counter actor as our key. And that's going to retrieve a reference that belongs only to this type. So when I want to go ahead and get access to my counter actor, in this case, we're getting access to the shard region or the generic child parentage actor for the counter actor here. So a whole hierarchy of potential actors. I can just go ahead and call registry.get, and I pass in my generic argument here again, which is going to be the counter actor type. Well, we also expose what's called a required actor, which takes in, guess what? Another generic parameter. This generic parameter, as long as it matches something that is stored inside the actor registry, will allow you to resolve via constructor-based dependency injection the matching and corresponding actor type here. So this counteractor.actorref is going to be the very same actor that we started right here. This makes it very easy for us to pass around references to actors, either other Akka.net actors potentially, or in this case, we're using a HTTP controller and resolving an actor this way. That way you don't need to explicitly get a reference to your actor system. You don't need a static class to stick actor references into anymore. You can actually do dependency injection properly this way using a DI container if you want to. So this is all part of the Akka.Hosting experience. Lastly, if you're in a scenario where you have something like a background service, for instance, this background service is going to start up at the exact same time that Akka.net is. Well, the actor registry may not be populated when the service first begins. The reason being is that Akka.net itself is starting up. So those actor registry entries may not be populated right away when you need them. So what we can do in this case is pass in either a reference to the actor system or a reference to the actor registry. Both of those components will be registered to the service collection anytime you use Akka.Hosting. And you can always get access to those immediately whenever you want to go ahead and get a reference to them. So we're going to pass in a reference to the actor registry that we're using inside this host, and we're going to call getAsync. This will allow us to asynchronously wait until this lead actor gets populated into the registry. That way we can go ahead and kind of block the execution of this background service until we know that actor is ready. And once that actor is ready, we can go ahead and begin messaging it or having it do whatever it's going to do behind the scenes. So these are all kind of the basic tenets of Akka.Hosting, and we're going to be using these in the .NET New templates that we're going to show in our demo at the very end of this video. So Akka.Hosting is one thing you should absolutely start integrating into your Akka.NET applications immediately. Don't wait. You should go ahead and start using it right away. The next library we're going to take a look at is Akka.HealthCheck, which integrates with the Microsoft.Extensions.HealthCheck ecosystem and provides some built-in checks for important tools like Akka.Persistence and Akka.Cluster. Under the covers, we use a Kubernetes-style approach to health checks. We have liveness checks, which basically check to see, can this process even function? If a liveness check fails, the process must be killed and recreated. That's what that means. Then we also have what's known as a readiness check. A readiness check is basically like a load balancer health check. The process might be running, but it may not be ready to serve traffic yet. That's what a readiness check really means. Well, if in the event that there's a failure, it means that this process may not receive traffic right away. But if you get a long failure, it means that this process must be killed, is what we're referring to here. So in the event that a readiness check doesn't pass within some certain configured window of time in Kubernetes, it'll be the same as a liveness check failing eventually. We'll assume that there's something wrong with the process and it just can't recover. When a readiness check passes, the load balancer will begin delivering traffic to that process. Akka.HealthCheck out of the box has a number of different targets. First, we have a default health check, which just makes sure that the actor system is running. Pretty basic. The actor system is not running. Obviously, Akka.NET can't function. We have a liveness check for Akka.Persistence that is really useful. Namely, we check to make sure that we can recover, we can write, and we can also delete data from the underlying journal and snapshot stores. In the event that one of these operations fails, we'll probably fail the liveness check, and this process should get restarted in that case. We also have an Akka.Cluster liveness check as well. This validates that we have successfully joined a cluster. In the event that, let's say, we get disassociated from a cluster and we get marked as down or unreachable, this liveness check will fail, and again, that should signal this process should be restarted. Finally, for readiness checks, we also have an Akka.Cluster readiness check, which indicates that not only are we in a cluster, but all the other nodes in the cluster are reachable. This readiness check might fail in the event that you have, let's say, a long period of unreachability throughout the cluster. Now, it's also very easy to customize which health checks you want to have enabled at any given time inside your system. And it's also quite easy to add your own custom health checks if you want to. We have a number of different transports. These are tools we can use to communicate whether or not a resource is healthy or not inside Akka.NET. So we have the ability to programmatically use actor pub sub to go ahead and subscribe to health check notifications if you want. That way your own actors can decide how to react to that information when it arrives. You can also use a TCP socket transport, which means that the socket gets closed when a check fails. This is an example of a Kubernetes style sort of health check system. We also have a file health check where we can go ahead and write health status data out to a file. That typically gets used in combination with something like a Kubernetes CLI health check. But probably the most popular approach I suspect we'll see out in the wild is the HTTP health check transport. This is done in combination with Microsoft.Extensions.HealthChecks, and this will use that health Z endpoint that is so popular now with a lot of ASP.NET apps. So to install Akka.HealthCheck and to integrate with the Microsoft.Extensions ecosystem, you want to install the Akka.HealthCheck.Hosting.Web package. I know that's a mouthful. That's just the name we picked. To integrate with Microsoft.Extensions.HealthChecks, we unfortunately have to make a few different API calls. And by the way, this is the same for virtually every other service that integrates with the HealthCheck ecosystem. So it's not just Akka.NET, but this will also be true for things like SignalR. One thing we have to do here is we have to go ahead and register with Akka.HealthCheck directly on the iService collection. And I'm going to pass in here HealthCheck type.all. This means that we're going to use all of the built-in health checks. If I only want to use a couple of them, let's say I only want to use the persistence health check and I don't want to use the cluster ones, I can pass in HealthCheck type.persistence. If I want to use the Akka.Persistence health check and let's say the cluster liveness check, but not the readiness check, these are bit masked, and I can do HealthCheck type.persistence and HealthCheck type. I think it's cluster liveness or whatever. We show how to do this in our documentation for Akka.HealthCheck, and there'll be a link to that in the description. Next, I need to go ahead and actually register the HealthCheck actors with my actor system. So I do that via Akka.Hosting. And then finally, If we want to go ahead and expose the Akka.HealthCheck HTTP route, we also have to register that route down below as well. So this kind of follows the standard sort of ASP.NET sort of system for doing configuration here. This is what the HTTP output looks like if we query the HealthZ endpoint, HealthZ/Akka. This will go ahead and give us a description of all the different little Akka services that we registered for HealthChecks, and it'll tell us what their status is. So down here, for instance, I can see that our recovery status for Akka.Persistence reports that the journals recovered, snapshot stores recovered, and that we were also able to persist to both, and that there are no failures. That's great. I can also see the cluster's alive, cluster's ready, and I can also see that our Actor system's up and running. We'll see a little demo of this in just a moment when I go ahead and I fire up our little web API demo that uses Akka.Management, HealthCheck, and Hosting. So the last library we'll take a look at is Akka.Management, which provides 3 critical capabilities for Akka.Cluster users. The first is the ability to automatically bootstrap a cluster. That means that we don't need static seed nodes anymore. We can discover them dynamically. And that leads us into the second capability, which is the service discovery components themselves. We offer several different NuGet packages for being able to discover who might be interested in forming a cluster right now and how can you contact them. And then finally, as an optional feature, we also introduced some distributed lock implementations. These can be used by tools like split brain resolvers and cluster singletons to essentially get a second opinion on who should be the real leader inside a cluster if we're doing a split brain resolution, or who should really own a cluster singleton in the case of that component as well. So let's dive into this. So first, Akka.Management provides an automated way to form clusters without seed nodes. That's the primary reason for using it. The way this works is we expose a non-public HTTP API, and then we also use a component called Akka.Discovery, and there's several different implementations of this. But what Akka.Discovery fundamentally does is it allows us to query available nodes and to add our own information about the node that we're currently running on to the discovery list. And we're able to essentially contact each of these nodes via their non-public HTTP API and use that to kind of negotiate who's available to form a cluster right now. Once a minimum quorum is reached, typically it's 3 nodes, we will go ahead and form a cluster and everyone will join that cluster. If nodes we discover are already a part of a cluster, we'll join that one instead. And what's so advantageous about this is that it helps us avoid the missing seed node problem during cluster formation or rejoining a cluster. If you're using Lighthouse before and you had an instance where you went ahead and restarted all of your Lighthouse nodes, you could end up in a scenario where you had multiple clusters form. That's a problem. So instead, using Akka.Management, we make sure everyone forms the exact same cluster, and there's no more dependency on these specific nodes needing to be available any longer. Instead, they can be dynamically discovered using this Akka.Discovery system instead. Generally speaking, this approach will be much more safer in production than static seed nodes. If you're using Akka.Cluster, you should certainly look at upgrading to using Akka.Management right away. Now, how does Akka.Management actually work? Well, first you have to pick an Akka.Discovery component. In this case, we're using Akka.Discovery.Azure, which basically has every single node in the cluster periodically update their entry inside a shared Azure table, and we query the Azure table every time a new node joins and needs to get a set of who are the possible nodes I can form a cluster with. Well, in addition to that, we also have a HTTP API exposed, on this case on port 8808. What's going to happen is that each one of these nodes who is currently not in a cluster is going to populate their entries into this shared Azure table, and then they're going to fetch that data from Akka.Discovery.Azure, and they're going to use that data to ping the HTTP endpoints of the other nodes they've discovered, because it's possible there might be stale entries inside that table that haven't been cleaned up yet. So once we go and query the other live nodes in the cluster, we're going to say, you know what? As long as we've reached our minimum quorum and we've been able to successfully contact all those nodes via their HTTP API, we're going to form a cluster. So the nodes that were all participating in this scheme will all go ahead and begin sending join commands to each other, and within a matter of seconds, they'll form a cluster. Any node that subsequently tries to join the cluster later will query the Akka.Discovery.Azure source again, and this time it'll get a list back saying, hey, here's a whole bunch of nodes that are already in a cluster. In which case, we're not going to bother doing the whole roundabout HTTP API querying again. We're just going to send join commands to those nodes, and as long as one of them is still there, we will go ahead and join that cluster. And this process is very resilient. It's also quite fast, particularly after a cluster is formed the very first time. And we're going to see a demo of it in action in a little bit in this video. Now, In terms of what are my available Akka.Discovery options? Well, we have Akka.Discovery to Azure, table storage. This works great. Honestly, it'll work in any environment. In fact, I think we're going to be using that locally on my machine in a minute using the Azure Table Storage emulator. But this is really designed for use with Azure hosted solutions. So you can use this to form clusters on Azure App Service or on Azure Container Apps, or if you wanted to use it inside, let's say, good old-fashioned infrastructure as a service, that would all work just fine. Next, we have Akka.Discovery.Kubernetes. This actually works by querying the Kubernetes APIs and scans for things like pod labels and environments and that sort of stuff. And we'll be able to use that to go ahead and dynamically form clusters as well. And then finally, we also have Akka.Discovery.AWS API.EC2, which uses tags essentially to go ahead and find available nodes to query and form clusters. There's also an ECS version of this as well, which again, also uses tags under the covers. Both of these are part of the same NuGet package. Then finally, we have Akka.Discovery.Configuration, which is built directly into the Akka.Discovery base library. This works very similarly to how static seed nodes do. The difference is that there's no constraints on ordering anymore, whereas with seed nodes, the first node in the seed node list must be available the first time you try to form a cluster. That is no longer true because of the HTTP mechanism that Akka.Discovery uses. We don't need to rely on ordering. As long as we have a minimum quorum of nodes, we should be fine. And this is all configuration driven. At some point in the future, we might add DNS as another means of doing Akka.Discovery. That'd probably be a good option for on-premise environments that don't have access to any sort of cloud metadata. The other option you can use for on-prem would probably be Akka.Discovery.Configuration. That should work just fine. Now, the way we install Akka.Management is through the installation of two packages. Well, depending on what discovery engine you're using. But you need to install Akka.Management. That includes all the base APIs for bootstrapping your cluster, and it also includes all the HTTP components as well. And then we need to add an Akka.Discovery component. In this case, we're going to install the Akka.Discovery.Azure plugin in this instance. Now, to actually configure this using Akka Hosting, we have to call a couple of methods. First, we need to go ahead and call the with Akka.Management method right here. This is going to pass in our settings for what host name we should use for being able to be contacted on the HTTP API and what port we're going to expose. So the Akka.Management piece is kind of like the inbound side. This is where we're saying, here's the HTTP endpoint we want to open for other nodes to contact us. Next, we need to go ahead and add cluster bootstrap. This is the outbound side where we're going to begin querying those endpoints in order to see who's available. So I'm going to pass in here that here's my service name. This is basically just a virtual service name. The idea is that you could potentially have multiple things that could all be discovered using the same Akka.Discovery component. For instance, we'll very likely add support for Akka.Streams.Kafka to use Discovery for being able to discover Kafka nodes to connect your clients to. That might be something we might do in the future. And in that case, you'd want to have multiple different service names to go ahead and distinguish them. So in our case, our service name is just some arbitrary string. We just want to make sure that Akka.Discovery and Cluster Bootstrap are referring to the same service instance here. So that value should be shared between those two. Next, we're going to go ahead and tell Cluster Bootstrap which port we are going to use to try to contact. This port here should match the same one that Akka.Management uses. And then finally, we're going to pass in the required number of contact points. This is basically our way of establishing a minimum quorum. So typically 3 is the value I'm going to use. Where I'm going to say, I need to make contact with at least 3 nodes before we can form a cluster. That's a reasonably safe value. And then finally, we configure Akka.Discovery down here, in which case, I'm going to go ahead and say this is with Azure Discovery, and this is the service name we're going to use. And here I'm going to pass a reference to our connection string for connecting to Windows Azure Storage right here. Now we're going to go ahead and move on to our demo, which is going to use some of the brand new Akka.NET templates that we've just published. So I'll go ahead and cut over to my IDE for that. So for our demo, we're actually going to use one of the templates built into the brand new Akka.Templates package. These are .NET new project templates that you can use to scaffold Akka.NET projects using the .NET CLI. Or, as it mentions in this note right here, if you install these templates, they'll also be accessible from inside Visual Studio and JetBrains Writer as new project templates. So it's totally worth taking the time to do this. So I'm going to go ahead and copy this. I'm going to go to my little console here, paste this in. And let's see, this should go ahead and install relatively quickly. There we go. I can see that we have 3 different templates here. We have an Akka.NET plus ASP.NET Core HTTP API. That's the one we want to use. This one already uses Akka.Management, Akka.Discovery, and it also uses Akka.Cluster sharding under the covers. So this will be a really great opportunity for us to demo it. All right, so what you're going to see here is if I open up Rider and I go to New Solution, you'll see after it has a chance to sync templates that all of these .NET New templates we just created using the Akka.Templates package are all available for new projects here. So I'm going to go ahead and call this, Akka HTTP API 1. That looks fine. We'll go ahead and basically just click Create on this. And let's see, this should just take a moment here to go ahead and create a brand new solution for us. And voila, I can go ahead and see that we've got 3 projects, our HTTP API to app, app.tests, and our domain. So I'll go ahead and give that a minute to load here. All right, so I've got my whole solution loaded in Rider now. So basically what this has going on in here is a fully blown HTTP application built on top of an Akka.cluster sharded entity actor. So if I take a look at our program.cs, you can see that we're doing exactly what you saw on the slides, loading app.settings.json, app.settings.environment.json, and some environment variables. So we're using that. And then we're calling configure web API Akka, and we're installing petabridge.command. We're also adding HealthChecks support down here and exposing the HealthCheck endpoint for Akka.net as well. Okay, so that all looks really good. Let's take a look at this method real fast. Configure web API Akka. So we're going to go ahead and parse the Akka settings from configuration, add it as a singleton to our service collection, and then all these other methods down here for configuring the actor system, the network persistence, are all going to load this value to configure themselves. So if clustering is enabled, we'll go ahead and use that. If clustering is not enabled, we'll go ahead and just return the builder right away. Otherwise, we'll go down here. We'll check to see if Akka.Management's enabled, and if it is, we'll go ahead and call Akka.Management with Cluster Bootstrap. And then depending on which discovery method we want to use, right now we only support Azure Table Storage, we'll go ahead and grab that connection string from app settings, and we'll inject this into the Azure Discovery component down here. Now you can also see if I scroll down that we're going to go ahead and configure Akka persistence. Right here, I'm actually stringifying a little bit of HOCON. That's because I originally wrote this before we had proper Akka hosting support inside Akka.persistence.azure. We do now, so I should refactor this. But basically, we go and we configure, depending on what our persistence mode is. This is a built-in setting that I added to this template. We can either do in memory, or we can use Azure. And in this case, if we're using Azure, we're going to go ahead and pass in that same connection string. And this will create a separate set of tables that we're going to use for actually storing data that belongs to our entity actors. And finally, if I scroll a little bit further down, you can see where we can go and configure our actors. We're actually going to use cluster sharding right here, depending on whether or not clustering is enabled. And if we're not using cluster sharding, we're going to kind of fake it using this generic child per entity actor. And let's take a look at my little counter actor right here. It's a persistent actor, has a set of subscribers, and we're going to recover data using Akka.persistence, and based on counter commands, we're going to use this to go ahead and essentially update our counter, periodically save snapshots, and then we also will go ahead and publish or send, basically depending on queries that come in. We can optionally send a copy of our counter value to a requester, and we can also go ahead and support people who want to subscribe to live updates to this counter as well. Okay, that's all well and good. You'll notice, if I go back to my configuration, we're going to be registering this shard region or this hierarchy of actors using the counter actor key. Well, that is also going to show up inside our little HTTP controller right here, where I have HTTP gets, HTTP posts, and puts that will allow me to either assign the counter's value, increment the counter, or fetch the counter's results. So these are all things that we're going to be doing behind the scenes here using just a little bit of HTTP magic. Now, one thing I will point out is that we also have support inside this template. If I take a look here, pull this up. We have support using some of the brand new .NET tooling for Docker to go ahead and produce a Docker image. And it's going to be called Web API Template-App will be the name of this template image here. I also have, if I pull up Sublime Text, that's also going to be the name of the image we're going to use to go ahead and launch a little Docker container. A network of several nodes and an Azurite instance. Azurite is like the local emulator for Azure Table Storage. That way we can run this whole workload without actually needing to fire up an Azure account if we don't want to. So that's what we're going to go ahead and use to kind of run this in a little small environment here. One other thing I should point out is that we have an environment called Azure, and this has the connection string in it, this little app settings.json file, for being able to connect to Azurite. You'll also notice that we're going to enable Azure Table Storage Discovery and Azure for Akka.Persistence as well. So we're overriding some of the environment values that are set in app settings.json using this Azure-specific environment. So we should see this take effect as long as the environment variable for this process is set to Azure. And lo and behold, if we go back to taking a look at our Docker Compose file, you'll see that we set the ASP.NET Core environment equal to Azure. And we also pass in our connection string again here as well. Okay, so I'm going to go ahead and build our Docker image real quick using a couple of little shell scripts that are built into the repo. Then we'll try launching the demo and see how it goes. So you'll notice I'm in the Docker folder of the solution. This is where my Docker Compose file is. I went ahead and ran a little command, built Docker image, and then I went ahead and launched my Docker Compose file. And so I've got a 4-node cluster going. In fact, yeah, I'll just go ahead and verify that. PBM cluster show. Yep, 4-node cluster going. And I have an Azurite instance also running inside my little Docker network here. So I got these 4 nodes all connected together using Akka.Discovery. Now, one little important thing I actually kind of forgot is the way the controller works here is we're using this IRequiredActor, counteractor type. This is going to dependency inject every time I hit one of these HTTP routes, a reference to that counter actor in our actor registry into this controller. That's kind of how we're integrating ASP.NET Core with Akka.NET in this instance. Now, let's go to our little Swagger endpoint here, which I have exposed inside my Docker container. And you can see here that if I say try it out, and I want to look for a counter with an ID of 100, or maybe I can just change this to a counter with an ID of A. You see that we're going to do a GET request to this endpoint. We're going to get a 200 back with a counter ID of A and a value of 0. Okay. So one thing I can also do is I'm going to go ahead and do a little post command here. Try this out. Go ahead and do a counter of A, and I'll go ahead and send, let's see, I think 100. And I'll hit this. And we'll get a response body back that, yes, we have now successfully incremented this counter by 100. And if I run it again, you'll see that the new value of the counter is now 200. And if I run my GET request one more time, we'll go ahead and see that we get 200 back. So there we go. We've got our whole HTTP API built on top of cluster sharded actors. If I change this identity to B, I should get a 0 back, which I do. Great. So we're talking to a different actor instance this time. Likewise, you can go ahead and see my HealthZ endpoint right here. We can see that all of the same endpoints I showed in our little JSON example earlier are all reporting back in here. Akka.Persistence is working, the cluster's ready, the cluster's alive, and the actor system is currently running with no problems. So that's all I've got for you today. I really hope you enjoyed this video. We tried to give you a lot of detail on how some of these new libraries will really help improve your Akka.NET experience. I also strongly encourage you to check out the Akka.Templates repository and the NuGet package. Go ahead and give us some feedback on whether you want us to add some new templates or maybe change the way the current ones work. These will help give you some out-of-the-box samples for simple and fairly complicated stuff like we just saw that just work right out of the box. So please go ahead and take advantage of it and let us know if there's anything else we can do for you. Thanks for watching. We'll catch you next time.